Hello everyone, welcome to Q Physics Academy. Actually, in the previous three class, we discussed about the three differential operators like divergence operator, gradient operators, and curve operators. Okay, and I hope all the lectures are beneficial for your preparations, and all of you understand what is the mathematical concept and what is the mathematical approach. Now, in this class, today's class, we are basically discuss a very famous functions. This is not a ordinary functions. This is just like a distributions functions, and which is nothing but Dirac delta functions. Okay, so in the previous class, we are discuss about very famous distributions functions, which is nothing but Dirac delta functions. Okay, Dirac delta functions. Dirac delta functions. Okay, so what is Dirac delta functions? It's not a ordinary functions. It is a special functions. It is like a distributions functions. Okay, Dirac delta functions is like a distributions functions. It's not a ordinary functions. It is a distributions functions. So Dirac delta functions, it's have definitions. First of all, we are trying to find out the definitions of Dirac delta functions. Dirac delta functions, delta x, it's basically denoted as 0 and infinity. 0 if x not equals to 0, 0 it's x not equals to 0, and infinity if x equals to 0. This is the definitions of the Dirac delta functions. And also another definitions of Dirac delta functions, it is equation number 1. Another definitions of Dirac delta functions is nothing but the integrations minus infinity to plus infinity delta x dx is equals to 1. I means the probability of this distributions functions is always 1. This is represented, probability of this distributions functions. Probability of this distributions functions. Probability of distributions functions. Okay, it's nothing but probability of distributions functions. These two are the definitions of Dirac delta functions. Dirac delta functions. Here, first of all, we are trying to understand what is delta x and what is the corresponding significance of x, and what is the physical meaning of this. What is the physical meanings of this delta x equals to 0 or delta x equals to infinity at the given point of x, that is x equals to 0 and x not equals to 0. What is the physical meanings and what are the graphical representations from the corresponding delta x functions we're trying to find out. So Dirac delta functions, graphical representations of Dirac delta functions. So first of all, graphical representations of Dirac delta functions. Graphical representations of delta x. Okay, delta x, not delta x, Dirac delta functions of Dirac delta functions, that is based Dirac delta functions. Graphical representations of Dirac delta functions. Okay, first of all, we are take three kinds of Dirac delta function notations. First kind is a delta x, and the second kind is delta x minus a, and the third kind is a delta x plus a. So first of all, from delta x is basically represented as like it delta x minus 0. And so here, these delta functions have a center point also. This is the delta functions, and these delta functions have a center of these Dirac delta functions. Here, for the given functions, for the given delta functions, x equals to 0 is the center of the Dirac delta functions. X is the Dirac delta functions. X equals to 0 is the center of the delta functions. Okay, center of the delta functions. Delta functions. What is the meaning of the center of the delta functions? Basically, at that point, we get peak value. We get peak value of this delta function. I mean, we get maximum value of this delta functions, Dirac delta functions. At x equals to 0, we get maximum value. Okay. And now for the second kind, if we go for the second kind, for the second kind of different Dirac delta functions have a center at x equals to a. For that, x equals to a is the center of Dirac delta functions. Dirac delta functions. Okay. And the second kind, it's first of all, for the second kind, to represent the second kind, we first of all simplify this third kind of Dirac delta functions. It is simplify it as like it delta x minus of minus a. That means the center of the Dirac delta functions is nothing but x equals to minus a. Okay, so for these delta functions, x equals to minus a, x equals to minus a is the center, of the delta functions. Okay, Dirac delta functions, center of the Dirac delta functions. So what is the meaning of the center? Center of the delta functions, center of the node. What is the meaning of this center of the delta functions? Center of the delta functions is means center of the delta functions, center of the delta functions means at x at that point, means at that point we get maximum value of the given functions, of the corresponding functions, of the corresponding delta functions. Okay, this is the meaning of this center of the delta functions. So what is the meaning of this center of delta functions? I mean, at that point we are basically get the maximum value of these Dirac delta functions. So now we're trying to find out the graphical representations of Dirac delta functions. Okay, so graphical representations of Dirac delta functions is nothing but, first of all, we take one-dimensional Dirac delta functions, and secondly we take three-dimensional Dirac delta functions. So first of all, we take one-dimensional Dirac delta functions. One-dimensional Dirac delta functions. Dirac delta functions. Okay, one-dimensional Dirac delta functions. So here we take three kinds of Dirac delta functions, and we also draw the graphical representations for the corresponding Dirac delta functions. So first kind, it's nothing but delta x, and it is equals to, basically it is written as x minus 0. That means that Dirac delta functions have a center at the origins. So we take a take a coordinate system. This is nothing but as like it, and the point it's x equals to 0. This is a point, and along this direction is delta x, and is here x. So now the graphical representations of Dirac delta functions is as like it. Okay, so we get the maximum value. We get the maximum value of this Dirac delta functions, and this portions is basically that portions. It's basically represented. That portions. It's basically represented the area of the Dirac delta functions, and the area of the Dirac delta functions. It's that's the portions. It's represented area of the distributions functions. Area of the distributions functions. Okay, area of the distributions functions. So area of the distributions functions, we take this here x equals to plus infinity, we take, and that side it's x equals to minus infinity. So area of these distributions functions is represented as area equals to minus infinity to plus infinity delta x dx, and it is nothing but 1. So area of this given Dirac delta functions is nothing but 1. All h1. It's always true. It always true. Now trying to find out another Dirac delta functions. Now we're trying to find out another Dirac delta functions and what is the graphical representation of this Dirac delta functions. Okay, for second kind of Dirac delta functions, it's like a delta x minus a, delta x minus a. For the given Dirac delta functions have center point at x equals to a, center point at x equals to plus a. Okay, so you get the peak value at x equals to plus a, not origin. So the graphical representations, it's looks like that. This is the x equals to 0 origin, x equals to 0. Now this point at x equals to a positive value, and we get the maximum amplitude or maximum value at that point. We plot these Dirac delta functions. This here delta x minus a, and this is the x. So now the graphical representations of this Dirac delta functions, it's just like it. Okay, as like it at that point. So these regions nothing but area of this Dirac delta functions. This region is nothing but area of the distributions functions, or area, and area is always 1. Okay, so area is always 1. So it means minus infinity to plus infinity delta x minus a dx, it is always 1. Okay, next we're trying to find out what is the graphical representations of delta x plus a. So delta x plus a, third kind is basically delta x plus a, and it is represented as delta x minus OB. And for the given functions, center point is at x equals to minus a. X equals to minus a. Now trying to find out the graphical representations of this Dirac delta functions. It's this is the point. That point is x equals to 0, and that is the point x equals to minus a. Okay, so this is delta x plus a, and that axis is x, positive x. Now the graphical representations of this Dirac delta functions. It looks like that. So basically, that point is represented as a peak point of the given Dirac delta functions, and the corresponding regions, regions is basically called area distributions functions. So don't worry about the point. We're trying to find out another concept to understand the concept very easy. This is the area, and it is nothing but equals to 1. It is nothing but equals to 1. So area is equals to basically minus infinity to plus infinity, delta x minus a dx equals to 1. So area for the corresponding delta functions, it's equals to 1. So now trying to find out some important concept, some important properties of Dirac delta functions. So now let's point out some important properties of these Dirac delta functions. So please take a heading like properties of Dirac delta functions. Properties of Dirac delta functions. Okay, properties of Dirac delta functions. So first properties is basically minus infinity to plus infinity, delta x dx, it's always 1. Now the second properties is as like it, f of x delta x minus 0 is nothing but f of 0 delta x minus 0. As a similar manner, third properties is f of x delta x minus a, it's equals to f of a delta x minus a. Fourth properties is basically f of x delta x plus a equals to f of minus a delta f of delta x plus a. These three are the similar properties. Both are the similar properties. We are basically elaborate in different form. So now we take fourth properties, and now we go for the fifth properties. Properties number fifth. It is equals to minus infinity to plus infinity f of x delta x minus a dx. It is nothing but integrations minus infinity to plus infinity f of a delta x minus a dx. Now f of a is a constant term, so we are outside of the integrations. So f of a integrations minus infinity to plus infinity delta x minus a dx, and it is nothing but 1. it is nothing but 1. We always know about. So this is equals to basically f of a into 1. So f of a. Okay. So we find out a very interesting or very important properties of Dirac delta functions. It is integrations minus infinity to plus infinity f of x delta x dx. It is nothing but f of 0. This is a. B minus infinity to plus infinity f of x delta x minus a dx. This is nothing but f of a. And C minus infinity to plus infinity f of x delta x plus a dx. It's equals to f of minus a. But all the case here, these three properties are basically hold for a specific conditions. What is the conditions? What is the conditions for three properties basically hold? What is the conditions for that? Three properties are basically hold for Dirac delta functions. Please take a note. Please take a note. Please take a note. Are basically limits must includes limits. Here basically limits is minus infinity to plus infinity. Okay, minus infinity to plus infinity always includes every kind of points. Kind of points. Limit, we change the limit, right? X1 to x2, then what happened? Basically, we take a concept. Okay, to understand the problems. Now we trying to now we write an important sentence, and this is basically an important concept regarding the conditions. So conditions, notice conditions. What is conditions? What is the conditions for these properties are basically hold for the data functions? The condition thing, but conditions is so conditions is nothing but limits. Such limits must be enclosed. Must be enclosed. Limit must be enclosed the origin of Dirac delta functions. Limit must be enclosed. If limit does not enclose these origins, then these properties are basically equals to 0. Okay, so limit must be enclosed the origins of Dirac delta functions. Okay. Okay, very good. These are the very important points. first order derivative. Okay, so step functions is nothing but theta of x equals to x. So it looks like that. That is the value step functions. Okay, it's converted to continuous functions as like it by first order derivative. The best example of that. This is the discrete functions and this is the continuous functions. Okay, so we are already cover the one-dimensional Dirac delta functions. In the next class, we discuss about three-dimensional Dirac delta functions. Also, some very important problems of TIFR and JEST, which are basically asked in on the basis of Dirac delta functions. So, note down each and every concept. That's a very important. In the previous class, we have only discussed about three-dimensional Dirac delta functions. Now, we give you homework problems. Please prove it. Prove it. The properties, first properties, delta k of x equals to 1 by k delta x. How can I get? How can we get this type, such type of properties? Okay, how can I get such type of properties? Prove it first of all. Prove the properties. Okay, in the same manner, in the same step, we are used to solve the previous two problems. We are solved the previous two problems. Again, we take integrations minus infinity to plus infinity f of x delta kx, and we follow the step. Okay, prove it. Let's prove it. It is very important. Let's remember and also prove it. Basically, you can follow the step as like it, minus infinity to plus infinity f of x delta kx and tx. This is the value. So you can find out the value of that and comparing both sides. Okay, these are the very important problems. I'll take another homework. Take another homework problems. Homework number 2. Homework number 2. Minus 2 to plus 2. 2x plus 3 delta 3x dx, and homework number 3, minus 1 to plus 1 9x square delta 3x plus 1 dx. Solve it all the problem, and in next class we start our lectures with the problems. First of all, we solve it and then we continue our lectures to take it three-dimensional Dirac delta functions. Okay, so in the next lectures we will continue with three-dimensional Dirac delta functions, and also very important fact regarding three-dimensional Dirac delta functions also discussed. This is very important. Next class is very important. Three-dimensional Dirac delta functions. It is basically used in electrodynamics. Three-dimensional Dirac delta functions is basically used in to solve any kind of problems in electrodynamics. So what is the corresponding mathematical expressions of three-dimensional Dirac delta function, and how can I get three-dimensional Dirac delta functions, and which kind of a differential operator is basically responsible to find out the three-dimensional Dirac delta functions. These are the very important consequences. So we'll discuss in the next lecture. So please revise all the concept in very constantly, and if any doubt regarding today's class, please message me or contact with me. And so today's class is basically stop here, and I will request it to you, please complete every lectures in your own time, and to make your own notes according to my lecture, and please solve every homework problems and send me all the solutions of the homework problems. These are the very important to analyze himself. Okay, so thank you, and thank you for watching this video, and also happy learning.